Hi guys, welcome once again to another section of Learning with Prepclass. I am tutor Chima and I'll be anchoring today's section. Looking at your screen, you're going to be seeing Jamb Chemistry 2018, all questions answered. Now this simply means that we are going to be solving past questions on Jamb Chemistry 2018 today, and we are going to be looking at questions 16 to 20 because in the previous section we looked at questions 11 to 15. Alright students, before we proceed, do not forget to subscribe to our YouTube channel, like our videos. When you look below there, you are going to see a notification bell. I urge you to click and activate the notification bell. When you do so, you will be the first to be notified whenever we have a content like this on YouTube. Do not forget to drop one or two comments on our comment section box. A comment can be a question, maybe in an area you need me to explain more. You can drop one or two questions and I'll be always available to answer your questions. You can be kind enough to share our videos so that we get as much views as possible. So students, without wasting your time today, let's go straight to the business of today. Question 16. If one of the following oxides is heated with hydrogen or carbon using a Bunsen burner, it will not reduce to the metals. Which one is it? If one of the following oxides is heated with hydrogen or carbon using a Bunsen burner, it will not reduce to the metals. Which one of them is it? Is it lead oxide? Is it magnesium oxide? Is it copper oxide? Is it tin oxide? Now, one thing is that hydrogen and carbon are reducing agents. They will reduce metallic oxides to the metal. But that is to yes, you will reduce metallic oxide to the metal. But that is only possible if the hydrogen or the carbon is more reactive than that metal in question. So if both of them are higher in the activity series or the reactivity series or the chemical series than that metal, maybe like lead, magnesium or copper or so, then they will liberate the metal from the oxide. If they are not, they cannot liberate that metal or reduce that metal. They cannot reduce that metallic oxide to the metal or liberate the metal from the oxide. Now let us see the activity series. Now I say consider the reactivity series below. It goes this way: potassium, sodium, calcium, magnesium, aluminium. Sometimes we usually omit carbon. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver. What am I even saying? Hydrogen, copper, mercury, silver, and gold. So if you look at the series, the metals that are below carbon can reduce them or liberate them from their oxides. The ones that are above carbon cannot liberate them from their oxides or reduce their oxides to the metals. Same thing goes with hydrogen. The ones that are below hydrogen can displace them from their oxides or reduce their oxides to the metals. The ones that are above hydrogen cannot. So if you look at all these elements, lead, magnesium, copper, tin. Lead is where? Lead, potassium, sodium, calcium, magnesium, aluminium, zinc. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. So we are looking at hydrogen or copper, and they are asking us which one. Will it be lead, magnesium, copper, or tin? Look at lead here, look at magnesium here, look at copper here, and look at tin here. So you can see that lead and tin are more electropositive than hydrogen. So hydrogen cannot liberate lead or tin from their oxides. Lead, tin, and copper, right? Lead, tin, and copper. Okay, so lead and tin are higher than hydrogen. So hydrogen cannot liberate lead or tin from their oxides or reduce their oxide, but hydrogen can reduce the oxide of copper. can liberate copper from its oxide because it's more electropositive than copper. Then for carbon will reduce both tin, lead and copper from their oxides, or reduce their oxides to the metal, because carbon is higher than both tin, lead and copper in the activity series. But look at what magnesium is. Magnesium is more electropositive than copper and hydrogen. So neither of them, both of them, they cannot liberate magnesium from its oxides or reduce magnesium oxide to the metal. So I said carbon and hydrogen are less reactive than magnesium, hence cannot displace magnesium from magnesium oxide. So out of all the oxides that cannot be reduced to the metal is by either hydrogen or carbon is magnesium oxide. So our answer is magnesium oxide. 17. The IUPAC name for this compound is, they're asking us what's the IUPAC name. Let's see. Now the IUPAC name, look at the way we do what we call the numbering system. You can number from the front, you can number from the back. But I decided to number this way and to take this one as parts of the compound. So 1, 2, 3, 4, to take it as a parent name, and that is butane. And this one that is here should be taken as the attachment or the attachee. So that's why I use a circle to circle it. Depending on the position of the attachee tells you how you number. That's why I say you can number from the front or from the back, but depending on the position of the attachee. But you must number in such a way that this attachee will have the lowest possible number. If I had numbered from behind, I would have numbered 1, 2, 3, 4. This attachee will have 3 rather. I have numbered 1, 2, 3, 4. This attachee will have what? 3. It will become 3 methyl. But I decided to number from the front to give this attachee a small number, 1, 2. It actually becomes 2 methyl. But if I had numbered from behind, it will be 3 methyl, and that's wrong because it must have the smallest possible number. So you have to number from the front. That becomes 1, 2, 3, 4, and that actually becomes 2 methyl. The name of this attachee is an alkyl, CH3. That's the first member, methyl. So from the numbering above, the attachment methyl, which is CH3, is on the second carbon atom. You can see it is here, making that 2 methyl, 2 being the second carbon atom, 2 methyl. The parent name is butane. This is 1, 2, 3, 4. This is an alkane, no double bond. So it's an alkane, and 1, 2, 3, 4, 4 carbon atoms is butane. So the parent name is butane, hence the name of the compound is 2-methyl butane. 2-methyl, 2, look at the 2 here, second carbon atom, methyl, the attachment, butane, parent compound. So that's 2-methyl butane, and our correct answer is C, 2-methyl butane. 18. An aqueous solution of a metal salt, M, gives a white precipitate with NaOH, so that's sodium hydroxide, which dissolves in excess NaOH with aqueous ammonia. The solution of M also gives a white precipitate which dissolves in excess ammonia. Therefore, the cation is. Now they are telling us that they added this salt of this metal M with the added dilute hydrochloric acid, dilute sodium hydroxide, NaOH in it. It formed a white precipitate. When you now increase the volume of NaOH, the precipitate dissolved, telling you that this salt or this ion metal M is soluble in excess NaOH. They now tried it again with ammonia. They added ammonia to the salt. Small quantity of ammonia, it formed a white precipitate. They now increase the volume of ammonia, pour plenty quantity of ammonia. The white precipitate dissolved. That tells you that this cation is soluble in excess ammonia and soluble in excess NaOH. So they're asking us which of them is that particular ion. Is it zinc ion? Is it cation? Is it aluminium ion? Is it lead ion? So which of them is soluble in excess NaOH? Now, I said that this is a confirmatory test for Zn2 plus. It is zinc. Out of all the cations listed, only zinc is soluble in excess aqueous ammonia. Therefore, M is zinc. Now, you see these four. Aluminium and lead will form white precipitates. In short, four of them will form white precipitates. But this is how we distinguish them. For aluminium and lead, their white precipitate will be soluble in excess NaOH, but insoluble in excess ammonia. Take note of that. The white precipitate formed by aluminium and lead 2 ions with excess NaOH, it will be soluble. But if you use ammonia, in excess ammonia, the white precipitate remains. It does not dissolve in excess ammonia. Calcium ion will form a white precipitate in excess NaOH and excess ammonia. Do you see the difference? But aluminium and lead 2 ions will form a white precipitate, but they'll be soluble in excess NaOH, but insoluble in excess ammonia. But calcium ion will be insoluble in both excess NaOH and in excess ammonia. But for lead, for zinc 2 ions, for zinc ion will be soluble in excess NaOH, soluble in excess ammonia. So that's a confirmatory test for zinc 2 ions or zinc ions. It is soluble in excess NaOH, soluble in excess ammonia. But these two are insoluble in excess ammonia. But while calcium is insoluble in both excess NaOH and excess ammonia. So the correct answer there is zinc. I believe you understand what I just explained. Zinc. 19. What is the concentration of solution containing 2 grams of NaOH in 100 centimeter cube of solution? Na is 23. I forgot to change this. I saw the error before. It's supposed to be 23. O is 16, H is 1. Okay, this was where I effected the change. Na is 23. Okay, Na is 23, O is 16, H is 1. And they're asking us the concentration of the solution of what they're asking us to find the concentration. Find the concentration of the solution containing 2 grams of NaOH in 100 centimeter cube of solution. So they're asking us that concentration is molar concentration. We have 2 kinds of concentration. We have mass concentration and molar concentration. We have mass concentration and molar concentration. So since they are not specific, we use the most or the more important one, which is molar concentration in moles per dm cube. So that's what we'll look for now. So they've given us 2 grams of NaOH and 100 centimeter cube solution. Now, number of moles of NaOH is N equals mass over molar mass. That's how we find number of moles, because we want to find the molar concentration. Molar concentration is the moles per dm cube, so we need to find the number of moles. So N becomes mass over molar mass. What's the molar mass of NaOH? NaOH, that becomes Na23 plus O 16, which is this, 23 is this one, plus H, which is this one. You add everything, you get 40 grams per mole. So the molar mass of NaOH is 40 grams. So using N equals M over M, remember that this your M is the reacting mass 2 grams. So N becomes M 2 over molar mass 40. That gives us 0.05 mole. We must convert this volume that is in cm cube to dm cube. We'll do that by dividing by 1000. So volume of NaOH in dm cube becomes 100 over 1000, 0.1 dm cube. So the molar concentration becomes number of moles over volume. Number of moles 0.05, 1 over volume 0.1 dm cube. If you use a can divide this, you get molar concentration equals 0.5 mole per dm cube. So the correct answer there is 0.5. 0.5 moles per dm cube. 20. How many atoms are present in 6 grams of magnesium? Magnesium 24. Number of atoms is 6.02 times 10 to the power 23. How many moles or how many atoms are present in 6 grams of magnesium? The formula is number of atoms, this Na, equals number of moles times Avogadro's constant. When they ask you to find the number of elementary entities, number of particles, number of molecules, the formula is number of atoms or number of particles or number of molecules or number of elementary entities equals number of moles times Avogadro's constant. That's 6.02 times 10 to the power 23. So we use this graph now to find the number of moles. So number of moles N equals M over M, mass over molar mass. So number of moles becomes mass, which is the reacting mass 6 grams over molar mass of magnesium 24. That will give you 0.25 moles. So number of atoms becomes 0.25 times Avogadro's constant. So number of atoms becomes this times this 6. 0.25 times this 6.02 give us 1.505 times this 10 raised to the power 23. Bring it. So the final answer becomes, change this to 2 decimal places. This is up to 5, change it to 1, add it, it becomes 1.51 times 10 raised to the power 23 atoms. So that's the answer. 1.51 times 10 raised to the power 23 atoms. Alright guys, we've come to today's section of Learning with Prepclass, where we looked at past questions on Jamb Chemistry 2018. We solved questions 16 to 20. If you look below here, you see a link. I urge you to copy this link, type it on your browser, and load it. It will take you straight to our WhatsApp group. When you join us on WhatsApp, you'll be getting updates, you'll be getting infos on the latest content we have on our YouTube channels. So till you meet again, I still remain Tutoshima. Bye.